Hello again, everybody. Welcome to our third and hopefully final virtual lecture for our drug education this spring. Again, I want to thank you for your flexibility with me having some other school commitments to attend to. I would much rather be in class with all of you, especially learning about how our brain works and how drugs interfere and impact our brain. But alas, I will see you next week. So go ahead and watch, get comfy, sit through this video and watch the whole thing. I will pose a question at the end of the video that you will then need to answer in your knowledge check or reflection. So take some notes, and also feel free to take a look at the other PowerPoint that is in your class under the week 2 module that's been published from the drug education book as well. That might help simplify some of the terms for this chapter, especially since we have a lot of neurobiology terms and ideas and things to do with the brain. So a little bit more of an anatomy and chemistry class today coming at you. Today's virtual lecture focuses on Chapter 4 in our book, The Nervous System. If you haven't read the chapter yet, I would highly recommend doing that first, or at least having your book next to you while you're watching this so you can flip through the pages and take a look at each of the concepts in the chapter. I'm providing just a very high level overview today, so there's many more terms and concepts in the book that you might not be familiar with, or you maybe learned in a science class in high school but haven't revisited since then. So definitely have your book handy for this because there's much more detail there. After that, you will have a knowledge check that involves 3 multiple choice questions and 1 short answer question. And then I will talk about assignment number 2, preparations, and then what to do for next week when we see each other again in class. We'll start Chapter 4 by framing the idea of homeostasis. Our body's goal is to achieve homeostasis, or as close to homeostasis as we can. You might be watching this video laying down on your futon in your dorm, or sitting in the library, or maybe you're listening while you're a passenger in a car. But while you are doing that, your body is doing so many behind the scenes things, really a balancing act to keep everything in balance and keep us functioning. So that is called homeostasis. So what are some of the things that our body balances? Well, we take it for granted, but our body temperature, our blood sugar, the fluid levels in our body, those things are done by our liver, our kidneys, our sweat glands, our pancreas, our hypothalamus. Those are all things that are going on behind the scenes. We don't have to constantly remind our body to maintain a optimal body temperature, or we don't have to manually, unless we are diabetic and our pancreas doesn't work, we don't have to manually balance out our blood sugar. So our body does all of this stuff behind us, or while we're going on without us even really knowing about it. However, psychoactive drugs, and remember the idea of drugs is any substance that causes some sort of change to our body and brain. So psychoactive drugs are all the drugs that are under the umbrella of what we've been talking about this semester. Psychoactive drugs are going to influence homeostasis. So they interfere, they get in the way with the way that our neurons send, receive, and interpret messages. You might remember neurons or neurotransmitters from a science class where you have a resting potential, depolarization of the neuron, and action potential. That's the all or none if there's enough of the message that's been sent. But drugs can get in the way of those action potentials. So if our body is telling us that we're cold and our body needs to shift our body temperature, or it's telling us that we need to go to the bathroom, or it's telling us that our blood sugar is low, drugs can get in the way of those neurotransmitter communications. So for instance, when people drink excessive amounts of alcohol, the active components of alcohol will increase our urine output. So sends messages to the kidneys for us to go to the bathroom more often. So our body wants to always stay in homeostasis, and it's a very fine little Goldilocks position, a very fine sweet spot for us to be in homeostasis, but then drugs kind of throw that off. And how do drugs throw that off? Well, I'm glad you asked. We're going to take a little bit of a dive into the science behind how our nervous system works. So when we study psychoactive drugs, when we can understand the parts of the nervous system, that helps us also understand how drugs interfere with those parts of the nervous system. So drugs, when consumed, they alter our perception, they alter our mood, and they alter our behavior through their actions with neurotransmitters. Again, you might remember the word action potential from a high school science class. And neurons are just waiting there for a message. When a message comes and that message is strong enough, then the action potential travels to the next neuron. So that's the picture that you have on your slide here if you're having flashbacks to high school science class. But we have a bajillion neurons in our body, and they all act kind of like the game of telephone, where some sort of action potential happens. It travels along the neuron and then gets sent or disseminated to the next one. So when those channels get blocked or those channels get activated, which drugs do both of those things, then things happen like the feeling of reducing pain or the feeling of being euphoric. So drugs play different roles or cause different things in our brain and body because of their actions. So within our nervous system, we have neurons and we have glia cells. Neurons are going to analyze and transmit information all over the body. And then our glia cells are what is really made up of our brain, or what our brain is really made up of. 90% of our cells in our brain are glia cells. And those serve as a blood-brain barrier, which is good because we can't just have everything getting into our brain, even though drugs can pass through the blood-brain barrier. And then our glia cells also really feed our brain the nutrients that it needs. So when we're talking about our nervous system, we have two types of cells, neurons or neurotransmitters, and then glia cells. But neurons do the bulk of the transporting of the messages from drugs. Within our nervous system, we have a few different components to it: the somatic nervous system, the autonomic nervous system, and the central nervous system. The somatic nervous system is really the front lines, so that's our first line of defense. That carries messages from our body back to our nervous system, and it controls our voluntary actions. So when you stub your toe or get your finger pinched in a door or grab a hot pot off the oven and forgot to have a pot holder, your body says, ouch, right? I stubbed my toe, or ooh, that was hot. So our somatic nervous system is carrying the messages from our body back to our nervous system. Also, when we tell ourselves, I need to pick my feet up because I'm going up the stairs, we are not consciously doing those motions, but our somatic nervous system is the one that is creating or controlling those voluntary actions. Then we have our autonomic nervous system. So if our somatic nervous system is voluntary actions, our autonomic nervous system is going to be involuntary actions. So those are things like our heart rate and our blood pressure. Our breathing, for the most part, we can control our breathing, but most of our breathing happens without us thinking about it, right? Not every second of every day am I saying, okay, Jen, remember to breathe again and again. Thank goodness, right? That would be very distracting. So our autonomic nervous system controls things like that, digestion, etc. Many drugs are going to impact those involuntary actions. So think about a drug like alcohol that is a depressant that lowers your heart rate, that lowers some of the functions that your body is doing to try to keep you at homeostasis. Within the autonomic nervous system, we have our sympathetic and parasympathetic portions. The sympathetic nervous system is our fight or flight. So when we are nervous, when we feel like we're in danger, when we need to get out of a situation, our sympathetic nervous system kicks into high gear. Things that it does include makes our heart rate go faster, right? So if our heart rate's beating faster, we get more oxygen to our extremities, we can run away or we can prepare to fight if we need to. Our pupils dilate. Our pupils get bigger so we can see more. We can take in the environment around us and make a decision. We get blood to our extremities. Our digestion slows down so that we aren't using energy to digest our food, but instead getting ready to run. So that's our sympathetic nervous system, fight or flight. Then our parasympathetic nervous system, that does a lot of the opposites. That slows down our hearts, that stimulates digestion, that brings about more of the relaxing feelings, more of the euphoria, more of the calm and happiness. So the neurotransmitters within our sympathetic and parasympathetic nervous systems, they often work in opposition of each other. So one neurotransmitter might be pumping out to get us to go and get excited and get moving. And then there's another neurotransmitter that is the opposite of that, that calms us down and keeps us in a more euphoric or happy or not fight or flight mode, I guess, so to speak. So sympathetic and parasympathetic nervous system operate within the autonomic nervous system. And then we have our central nervous system. That is our brain and our spinal cord. So sensory nerves come in to our brain and spinal cord. So the sensory nerves that you have on your fingertips and your feet and your ears and your legs, those all come in and bring in with them the information that they've gathered. And then motor nerves go out from our central nervous system. So out from our brain and spinal cord, back out to the extremities. That's where our drug actions take place. So chemical pathways in the brain are going to influence things like learning, memory, integration of information, and coordination. So I'll say that again. These pathways in the brain, in our central nervous system, they are going to influence things like learning and memory, the way we integrate and understand information, and coordination of activity. So when drug actions change those or block those or get in the way, then those things can't necessarily happen. So think about what you know, maybe regarding some drugs and memory. Maybe you or somebody you know has had too much to drink and then they can't remember everything that they did the next day, right? So that would be an example of the drug action of alcohol and how that has suppressed or blocked the brain's ability to create memories. Same thing with alcohol and coordination. When people have had too much to drink, they slur their speech, they aren't able to walk straight, they certainly shouldn't be driving or operating motor vehicles, right? But coordination, the messages that are coming for coordination from the brain, the drug interferes with that or disrupts that. So a figure here on your slide, figure 4.7 from the book, shows an example of a possible way that these little messenger cells are hopping from one neuron to the next, right? These little neurotransmitters are traveling. So whether that is dopamine or serotonin or acetylcholine, these neurotransmitters travel in between the synapse from one neuron to the next neuron. So you don't have to worry about knowing all the specifics of the chemistry of the way that works, but it is helpful to imagine drugs kind of like imagine them like little cars or little bugs in your system, and they travel along and then hop. The message that they bring hops from one neuron to the next, and then that interferes with things in our autonomic nervous system. So just what is the roadmap for these chemical pathways? Like how do drugs, where do they go? How do they know where to go? And how do they affect things? We'll be spending more time on Monday when we're back in class together with neurotransmitters, but I want to give you an overview. I find this very fascinating myself, and I have heard of these neurotransmitters before, but I didn't know what they all did and or how drugs might interfere with them. This is not a neurobiology class. Again, you're not going to be quizzed on every single neurotransmitter and how it is formed and what it does, but it is good for you to have an idea of when somebody consumes drugs, those psychoactive properties change the way that our brain operates. And these are the superhighways that it changes. So different neurotransmitters cause our nervous system to do many different things. And the drugs that impact those neurotransmitters, that really helps you see the physical and psychological side effects of the drugs. So these drugs are passing the blood-brain barrier, and they're causing direct effects on the system of our brain. So the book has many more details about how these pathways work. So feel free to read through those and take a look at the other slides that are on our class page on D2L. There's a nice slide that has kind of a graph of all the different neurotransmitters. But let's take a quick run through them right now with these chemical pathways. So the ones that you're going to see the most involved with drug interactions are the ones listed here. We've got dopamine. That is our reward system. We get hits of dopamine all the time. When I know that I am home and I have a bag of candy waiting for me, and that first Starburst candy that I put in my mouth, ding, a little hit of dopamine. How else do we get hits of dopamine? Ding, somebody commented on our social media. Ding, we got a text from somebody that we like, right? Dopamine is our reward system. We want to keep doing those things to reward ourselves. So many drugs impact our dopamine chemical pathway. We've got acetylcholine. That is used with the formation of memory. So drugs can certainly impact the way that new memories are formed in our brains. We've got norepinephrine. That deals with arousal and attentiveness. So having caffeine or a stimulant would make us more attentive, more aroused. And then there's drugs that bring down that arousal level and bring down that attentiveness level. We've got serotonin. This chemical pathway kind of controls impulsivity and aggression. So serotonin can also be known sometimes as the cuddle hormone, where when you are surrounded by other people you love, little babies, fun things that make you happy, those serotonin levels are high, and that makes you want to continue to stay in a place like that. When serotonin levels are low, we might get a little more impulsive, we might get a little more aggressive. So drugs impact our serotonin levels. GABA. GABA is an inhibitor, so it tells us, it kind of stops us from doing things or not doing things. Think about a big stop sign. People who have perhaps poor impulse control or take a lot of risks maybe have lower levels of GABA. There are drugs, again, that lower our levels of GABA and make us feel like we can do things we maybe wouldn't have done otherwise. So alcohol might be a GABA inhibitor. It inhibits the message that, hey, this maybe isn't safe or this probably isn't a good idea. So low levels of GABA might be a concern with that. And then we've got endorphins. That's pain relief. Endorphins come from things like exercise, things like, oof, I just finished a big quiz or a long day at work, and now I get this flush of hormones out here that make me feel like, oh my gosh, I'm on top of the world. All my duties are done for the day, right? Or exercise for sure is a endorphin that our body pumps. Exercise creates endorphins that make us feel like, hey, I could keep going, or the pain isn't as bad anymore, right? I can make it to a next higher level. Endorphins, we often seek those out just like we seek out dopamine because we like that relief of pain. So these are examples of just a few of the chemical pathways that drugs might interfere with, and sometimes the drugs up these chemical pathways, more dopamine or less serotonin or less acetylcholine or more endorphins. So it's a big recipe for a lot of different changes that happen in our brain and in our body due to these drug actions. So what does our brain look like on drugs? What happens when I snort cocaine or shoot heroin or take a pill or drink alcohol or smoke a cigarette? These drugs arrive via the blood supply and they go everywhere. So they get metabolized in our liver. They go all over the place. They get into our brain. But not every drug acts on every receptor. So the drugs are searching out. Again, here's my imagination of a superhighway of little cars trying to find the right exits. They act on the receptors that fit for them. So if I have taken a stimulant, that might find my dopamine receptors and my endorphin receptors, and then the stimulant might mimic what naturally occurs in my body. So it finds the receptors that fit for them. It might get synthesized. It might get stored. It might have reuptake. It might get released, or the neurotransmitter might be metabolized. So some drugs mimic. That's called an agonist. So they are kind of in replacement of a naturally occurring substance in our brain, or it might block. So again, going back to alcohol, alcohol would block the inhibitors, and we'll get much more into this when we get to alcohol. This is confusing to me, but I like to say it out loud so I can have you guys imagine it too. Alcohol inhibits our inhibitors. So if we are in our right mind and we think it's probably not a good idea to climb the fence and streak the football field, right? When we're in our sober mind, we're like, this doesn't seem like a good idea. But then we have a few drinks, we get some friends who are egging us on because they've been drinking, our inhibitions have been lowered because alcohol is blocking the message that our brain's like, probably not a good idea. Alcohol kind of glosses over that, and all of a sudden we're like, you know what? It sounds like a great idea to climb this fence and streak the football field, right? So alcohol is, I'm not speaking from my own experience, but alcohol inhibits some of these neurotransmitters and the things that they are meant to do for ourselves. So that would be an example of a blocker where it's an antagonist. It is blocking what's supposed to naturally occur. Then our body acts accordingly. Then we climb that fence, or we get in a car and drive, or we dance for 5 hours in a row when we're on a stimulant, or we stay up and play video games because we're high on caffeine. So our body acts accordingly to what these drug actions take in our brain. And again, this is not just illicit drugs. So it's not just cocaine and meth and heroin and other opioids. It's things like sugar, right? I can definitely speak to this. I eat sugar and I want more sugar, and it makes me hyper and I want to seek out more of it. People who gamble, that is a self-reinforcing little dopamine hit every time. Or when you win, you get a rush of endorphins. You like that feeling of winning. When you're in love, there's a lot of chemical processes that are happening in your brain that are like drugs. So your brain responds to these things accordingly based on the neurotransmitters that are being affected. Pretty fascinating, huh? So many drugs do have reinforcing properties, whether it's physical or psychological. Like we talked about earlier this week in class, people seek out that same feeling again, maybe because it takes them away from the hurt and the pain that they're having in their life. They feel like they can be another person. They like the way they feel when they consume that drug. So there's definitely reinforcing properties when it comes to drug consumption. However, there are also a lot of other things in our lives that can feel very rewarding for us, and we don't have to use drugs to get there. So that segues us into our next assignment number 2 for this class, which is, hey, who needs drugs to have fun? This assignment is going to be due on February 1st, and you are taking a look at places both in your hometown and in St. Paul that are ways for you to get connected with people, feel good about yourself, be in community, be of service, entertain yourselves without needing alcohol or drugs. If you grew up in a small town like I did, There maybe weren't as many options. We didn't have a bowling alley. We didn't have a lot of recreation opportunities. And sadly, I believe a lot of my high school classmates did seek alcohol and drugs as a form of entertainment because there weren't other things to do. But maybe you grew up in a big city and there was a comedy club and major league sports and a roller skating rink and um, pottery classes, and you could join a video game club. I'm just throwing a few examples out there, but what you are going to look for is 6 different categories, both from your hometown and from St. Paul. Those categories are listed below here on the slide. You can also find this assignment when you click on the assignments tab or under the week 3 tab. We've got sports related, fitness, recreational, so that's going to be different than fitness. I mean, fitness and recreational can be seen as the same for some people, but maybe recreational is like, I belong to a chess club, or I'm going to a cooking class, or I am part of a rowing club. That could be fitness and recreational, but I want you to think more than just exercise. So we've got sports, fitness, recreation, academic. Do you have a library? Are you learning Mandarin? Charitable. How do you give back? What types of activities and opportunities are there for you to serve in your community? And then cultural. How do you get exposed to something that's different from the way you grew up? So 6 categories. I want you to list at least one. Did I say at least one? Yes, at least one suggestion from each of those categories. So you're taking a look at your hometown. So perhaps you grew up in Moorhead, Minnesota. All right, what was one sports related thing you could do in Moorhead? What was one fitness activity? What was one recreation activity? What was one academic, charitable, cultural? And now you're in the Concordia St. Paul area, so I want you to do some research around, hey, what's around in our neighborhood? If you are living at home right now, or say you live in Minneapolis, cool. I want you to do a list of things you could do in Minneapolis, but then also what's available around here. I don't think you'll be surprised to find that there are examples of all 6 of these right at Concordia, right, with all of our student engagement and student life and athletics opportunities. So you're just creating a list of both of them. It's a Word document. Give me a little introduction to get started with. Talk about all the things that you have in your hometown. Or if you're from a small hometown like I was, what could be something you could create? Be like, my hometown didn't have pickleball, but if that was an option, that would be my fitness category. That would be my recreational category, right? So 6 examples from your own hometown and 6 examples from the Concordia St. Paul community. Ways that you can have fun without having to use drugs or alcohol. So this will be in a written document, 2 to 3 pages, double spaced. Make sure you're taking a look at the rubric so that you meet all the assignment criteria. And you've got a little over a week to do that. After you've watched this lecture, you can then navigate yourself to our next knowledge check. You can find that under the quizzes tab, or you can find that under the week 2 content module in KHS 310. This will be due Sunday, January 27th at 11:59, and that knowledge check will disappear. So if you're watching this video maybe Friday afternoon or Thursday night, don't forget to go and complete your knowledge check before Sunday, because after Sunday at 11:59 it won't be visible for you anymore. So the knowledge check has 3 multiple choice questions. Each of those questions is worth 1 point. And then there is 1 short answer question. And here is what I want you to answer for the short answer question. So if you want to pause the video, get out a pencil and write it down, you certainly can. Or if you're watching this video with closed captioning on, then you'll see what I have to say in the closed captioning. But the short answer question is this. On page 109 in your book, there is a blue highlighted box that talks about the unintended consequences of viewing addiction as a brain disease. So, many of us try many different drugs, but only a small percentage of people become addicted to the point where it takes over their whole life. So read through this blue box on pages 109 and 110. The blue box is arguing that we shouldn't just be calling addiction a brain disease because we're doing a disservice to people. You might agree with that, you might not agree with that, but read through the blue box on pages 109 and 110 and then share with me your opinion on this unintended consequence. What do you think about what you read? What's your takeaway from this idea? So the short answer will be at least five questions, or excuse me, 5 sentences. So you can certainly scratch that out before you go into the knowledge quiz. So you have 3 multiple choice questions in the knowledge quiz. And then your short answer question will be from pages 109 and 110. Read the blue highlighted box that talks about the unintended consequences of how we view addiction as a brain disease. And then share with me your opinion. There's no right or wrong answers, but I just want to know what's your own personal takeaway from that idea about what the book introduces. Then you can see here on the slide, when we see each other again in class, it will be January 26th. Please read Chapter 5 and be ready for a in-class knowledge check on that. We'll be doing more talk with neurotransmitters and the actions of drugs in the body. And then we're going to just keep chopping away. It's a chapter per day. So I know this class is pretty heavy on the reading, but each chapter gets covered with each class period. So you're hopefully feeling confident with the material. And then February 1st will be your assignment on what can I do to have fun without drugs. Thanks for listening today. Take care, everybody. Have an awesome weekend. Hopefully you are able to stay warm, and we will see you back in class again on Monday. Bye.